Okay, good day. So today we will discuss the solution in our midterm exam. So in number 1, given sa atin yung vacuum pressure and also the atmospheric pressure. So I will read the problem. A tank has a vacuum gauge attached to it indicating 14.9 psi where the atmospheric pressure is 1.75 bar. So different given. So different ang given dito, pero papakita ko kung paano siya isusolve. So determine the absolute pressure in the tank. Given sa atin yung letter A, the kilopascal, B, psi, and C in bar. So the solution now here in the problem, so given sa atin yung atmospheric pressure natin. If you view our video lecture, so may intindihan ito. And since the problem indicates that it is a vacuum pressure, so pababa siya class, this is now your vacuum pressure, and this is now your absolute pressure. So in computing for the absolute pressure, that is equal to atmospheric pressure minus the P vacuum. Since the given is in 14 psi and bar, so convert mo lang to. Just need to convert first the bar. So 1 bar, how many kilopascal? That is 100 kilopascal. And also this 14.696 sa taas, i-convert din natin into kilopascal. So, yun ang gagamitin nyo class in converting is the 1 atmospheric pressure, which is 101.325 kilopascal, or you can use the 14.696 psia. Okay? So, we will use that, the atmospheric 14.696 psi, 101.325 kilopascal. So, what is now the answer? Compute for this calculator. So, we convert this. So, this is 102.783 kilopascal. And this one is also equal to 100 times 1.75. 175 kilopascal. So in letter A, in solving for this, the absolute pressure now is equal to the atmospheric minus the vacuum pressure. So 175 kilopascal minus 102.73 kilopascal. So your pressure here is equal to, this is now equal to 72.27 kilopascal. Also in letter B, the required is in psia, so you have now the absolute in kilopascal. You just need to convert this using the atmospheric pressure, the standard atmospheric pressure, which is 101.325 kilopascal, and this is 14.696 psia. So in letter B, your absolute pressure now is equal to 696 over 101.325. We have now 10.48 psi. Cancel yung kilopascal, matitira is psi. And then letter C is in bar. Pag bar class, you just need to your absolute, the 72.27 kilopascal, times mo lang siya by 100 kilopascal. Baliktad class. So, yung 1 bar natin, 1 bar is equal to 100 kilopascal. So, this is now your absolute pressure. So, i-divide po lang by 1, that is now 0.70227 bar. So, that is now your solution in number 1. Okay, given then sa atin in number 2, a barometer can be used to measure an airplane's altitude by comparing the barometric pressure at a given flying altitude to that flying altitude to that on the ground determine the airplane's altitude. If the pilot measures the barometric pressure at 25.10 inch Hg, while the absolute underground reports it to be 30.02 inch Hg absolute. So where the average air density is equal to 0.077 pound mass per cubic feet, wherein the gravity is equal to 32.174 feet per second squared. So given sa atin yung first, the pressure, the given altitude, and also the pressure, atmospheric pressure, the density of the air, and also the gravity. So the required is the height. So ano yung altitude natin? So the solution now excuse me. So given sa atin yung dalawang pressure and the pressure too. So what is now the height? So computing for this, we all know that the change in pressure is just equal to the density times the gravity times the height. Okay, so computing for the height, we have now the change in pressure divided by the density times the gravity. Okay, take note that the change in pressure, we need to compute for the change in pressure. So the pressure 2 minus pressure 0.1. So given sa problem is 30.02 inch Hg minus the pressure at 0.1, 25.10 10 inch Hg. So computing for the pressure, we have now 30.02 minus 25.10. We have now 92 inch Hg. So since you know the units is in English unit and it is also in cubic feet, you need to compute for that. So convert this first and to PSI. We all know that the 1 atmospheric pressure is equal to 14.696 PSIA, and it's also equal to 29.92 inch Hg. Convert this first. Seeing the atmospheric pressure, 29.92 inch Hg. So we have now the change in pressure, 14.696 divided by 29.92. So we have now 2.42. Titira sa atin is PSI. And this PSI is equal to pound per square inch. Since in the problem it is in cubic feet, take note, convert na natin siya into cubic feet later. So balik tayo dun sa general formula wherein change in pressure over the density times the gravity. 242 pound per square inch. Convert natin into cubic feet. So we have square feet. So have 144 inch squared over 1 square feet over density. What is our density given sa problem? 0.077 pound mass, okay, per cubic feet. Take note, since this is pressure, that this is now considered as pound force kasi force over area. So this is now in pound force. Okay, and also the gravity is 32.174 feet per squared. So balikan nyo yung constant proportionality natin. So para ma-convert natin to, we will use the proportionality K, 32.174 pound mass feet all over pound force per second squared. Okay. Sige nga, by unit analysis. So, by unit analysis, anong matitira sa atin? So, we will use other. Pound force, makakancel. Inch, inch. And the pound mass, pound mass. Take note of this. The second squared, makakancel din. Matitira na lang dito sa taas. Kung sa taas muna tayo, feet squared times feet. Okay. Matitira na lang is 1/feet. Sa taas yan. Dito sa baba, cancel, feet squared. Okay. So, 1/feet, foot. Okay. Over 1/feet squared. Ano yung reciprocal nito? Feet squared. 1, matitira na lang is feet ang unit mo na. Take note, we have same number, so cancel mo na din to. So, matitira na lang is 2.42 times 144 divided by, divide natin siya by 0.077. So we have now the height now is equal to 45.71 feet. So this is now your answer. So take note the conversion, so it is just very easy. Just use the atmospheric pressure and also the proportionality concept. Okay. So this is now the answer in number 2. Okay, so in number 3, the given is the figure wherein you can see the YouTube manometer, double YouTube manometer. So we need to calculate the pressure, the absolute pressure at point 1. So here is point 1. Take note of that, of the manometer shown in kilopascal. So the local atmospheric pressure is given as 780 millimeter Hg. So the fluid A is so given certain specific weight and also the specific weight at fluid B. We have the distances. So what is now your solution? So take note, in the red here, you can see we will denote this as Px and the Px prime. So in Px, kasi in Pascal's law, at any point or any level, parehas yung pressure nila. So in the line x to x prime, so we have the pressure at x is equal to the pressure at x prime. Take note, the pressure at x is equal now to pressure point. So yun yung hinahanap natin. While in pressure x, so kita nyo sa figure, we have here the axis x prime. So ito yung pressure gauge niya at 5 cm ng fluid A, and another line, red line at the top. So this is denoted as y and y prime. So y and y prime, so this is now your py, the pressure at point 1. So we have now the px prime now, so we add mo lang daw yung sa taas niya, automatically yun yung pressure. The pressure gauge of fluid A at 5 cm plus the pressure at point y. So balik tayo dito sa picture. So here, may pressure point naman tayo dito. Vertical axis, horizontal axis, the y prime is equal to the pressure at point y is equal to the pressure at y prime. Okay. So the pressure at y is equal to pressure at y prime. So take note dito sa figure sa y prime, we have 15 cm in the atmospheric pressure. So kita nyo the pressure y prime, may pressure gauge din tayo at 15 cm sa fluid B and the atmospheric pressure. So your pressure y prime now is equal to the pressure gauge gauge ng fluid B at 15 cm plus the atmospheric pressure. Okay, dugtong natin. Sabi ko nga, yung pressure X daw is equal to pressure 1. Substitution class. Ito yung pinakauna. Pressure at point 1. So, the pressure 1 now is equal to, sabi natin, Px is equal to Px prime. So, the pressure 1 is Px prime. Ano yung Px prime natin? Ayun. So, the pressure gauge at fluid A, 5 cm plus the pressure at Y. Ano naman yung pressure natin at point Y? Ito. So, pressure 1 is equal to pressure gauge at A, 5 cm plus Y prime. Diba? Ano yung equivalent ng Y prime natin? Ayun. So, the pressure at point 1 now is the pressure gauge at fluid A, 5 cm plus the pressure gauge of fluid B at 15 cm excuse me, plus the atmospheric pressure. So, computing for the pressure, we all know that is equal to density times the gravity times height. But your density times the gravity is also to the specific weight times the height. Okay? Balikan nyo yung conversion natin na the pressure at point 1. So, the pressure, the fluid A, the specific weight of A times the height A, plus the specific weight of fluid B, plus the height B, plus the atmospheric pressure, which is equal to, given sa atin yung problem. So, this is now your formula. Finding for the pressure 8, so 13 kilonewton per cubic meter times the height. So, 5 centimeter, convert nyo into meter. That is now 100 centimeter. Okay. Plus the pressure at point B. Ilan yung pressure na natin? Specific weight is 8 kilonewton per cubic meter times the 15 centimeter times 1 meter over 100 centimeter plus the atmospheric. In the problem we use 780, so we have 780 millimeter HD. I-convert natin siya sa kilopascal, kasi mangyayari dito makancel yung centimeter, makancel yung meter, so kilonewton per meter square, so kilopascal. So use the absolute 3125, the atmospheric pressure over 760 millimeter Hg. Okay, computing for the pressure at point 1 now, that is equal to, so yung 13 mo i-convert natin sa 5. Okay, so we have 0.65 kilonewton per meter squared, which is now equal to kilopascal plus 8 natin, 15 divided by 100. So we have 1.2 kilonewton per square meter. This is also kilopascal. Plus yung 780 millimeter Hg natin, makancel yung millimeter Hg, matitira is kilopascal. So 780 times 101.325, so times 760, I divided by 760, so we have 103.99 kilopascal. So your answer in pressure 1 now is 1.2 plus 0.65. This is now your answer, 105.84 kilopascal. Okay.